Welcome! I am very excited that you decided to join me today for this course on Explainable AI. Have you ever asked questions like, which is smarter, humans or AI? What might be the next big thing after AI? Is it possible for humans and computers to get along better? Or, what in the world is Explainable AI? Then stay tuned. We're going to dig into the fascinating world of AI, their strengths and weaknesses, the ways that humans can better work together with them, and, of course, what Explainable AI is. Although AI can be a powerful tool, one of its biggest drawbacks is that it cannot tell you why it made a certain decision or recommendation. It is essentially a black box. XAI is a type of AI that will also give us insight into the reasons why an outcome was recommended. In this course, we'll talk about what it is, how it works, why you might use it, how you could benefit from it, and what you should do about it. My name is Aki Ohashi, and I am a Director of Business Development for the Palo Alto Research Center, or PARC, the Xerox Research Center that invented technologies such as the personal computer, laser printer, Ethernet, and the graphical user interface. Today, PARC continues to conduct research in some of the world's most advanced technologies, including printed electronics, optoelectronics, AI and machine learning, blockchain, as well as explainable AI. At PARC, I oversee business development for all of our clients in Asia-Pacific and Australia and New Zealand, with some of the largest companies in the world. Many of these companies are already deeply involved in AI technologies, and some have started their journey into XAI. We've got a lot to cover, so let's get going. With the proliferation of artificial intelligence and machine learning algorithms in the world, it is getting more and more important for human beings to be comfortable with using these sometimes mysterious systems. Before we get into the details of XAI, I will take a few minutes to review the basics of AI, machine learning, deep learning, and go over some other terms used throughout this course. Artificial intelligence, or sometimes called machine intelligence, refers to a very broad set of technologies that is developed to make computers or machines intelligent. Now, the term intelligence itself is subjective and can be defined differently depending on who you talk to. There is certainly a lot of ambiguity about what AI actually is. In fact, some people like to say that a system is only called AI until it becomes used in everyday products. Then, it's just technology. We don't need to worry about these distinctions in this course. It is sufficient to just know that the AI we will refer to here is generally what is discussed in the media and in business situations. Now, let's talk a bit more about what an AI system is. If we massively simplify things, these systems have three main parts. There is the input, there is a model or algorithm, and there is the output. Inputs are the data that you want the AI to analyze. These could be some photos, data from a factory, or sensor information from your self-driving car. The outputs are the decisions the system makes. Continuing with the previous example, it would be the fact that the picture is of a cat, the settings you need to make the factory run smoother, or the fact that your car doesn't run into something on your way home from work in autopilot mode. Then there's the meat of the system, the model or the algorithm. This is the part that does the actual analysis of the input data to get the output. There are many different types, far too many to get into here. Within the large category of AI, there is a subset of methods that uses statistical techniques to learn how to classify or predict outcomes from an existing set of data. This is what's called machine learning. As the name suggests, the system is taught or trained to be able to make these classifications or predictions. Briefly, in machine learning, you would need to prepare a large amount of data, called the training set, to teach the system. We'll talk a little more about the details of this in a subsequent slide. If we go one level deeper within machine learning, we have deep learning, which is based on architecture that is somewhat similar to how our brains work. In fact, deep learning is really just a new name for neural networks, a system that has existed for years. We'll talk a bit about deep learning, as this is often the system that researchers are trying to make more transparent by making it explainable. Here we have an example deep learning system. You can see that we have an input layer, hidden layer, and output layer. Often, there are many hidden layers, depending on the specifics of an application. In general, the input layer will break down the data it receives into basic elements, and then hands them off to the first hidden layer. In the example of a photograph, these basic elements are often individual or small groups of pixels. Then, each set of hidden layers will group these into larger components that it finds. For example, edges of objects, groups or combinations of edges, larger objects, and so on. The final layer again is the output layer, which is the decision or recommendation that you want the system to make. In the cat example, it would be the decision of whether the photo is of a cat or not. A big problem with AI systems today is that the process is not transparent. If you asked your friend to perform the same prediction task, she may pick a photograph from a pile and tell you that this is one of a cat, and that she is quite certain about that decision. If pressed, she could also explain to you that she came to this conclusion because she identified square ears, long whiskers, and paws that she associates with cats. Unlike humans, however, current AI systems cannot explain to you how it came to its decision. In the trivial example of cats, let's start by talking about why we need XAI. Here's a simple example. I'll start by asking you a tough question. What do you think this is an image of? And if you think you got the last one, what about this one? Okay, those first two might have been pretty easy, but what about this one? And finally, this one? The answers might surprise you. Since this is a course about AI, it would be interesting to ask an AI system what it thinks these images are. In fact, that is what some AI scientists did in some research conducted in 2015. They fed these images into the state-of-the-art deep neural net, a type of AI. The first two answers here were not surprising. The system decided they were images of a guitar and a penguin, much like what most of you probably thought. The numbers shown are not the probabilities of the answer being correct. They are the degree of confidence that the system thinks that it is correct. Let's see what the system thought the other two images were of. As you can see, the system also thought the other images were of a guitar and a penguin as well, at extremely high confidence levels. How could this be? In fact, this was a rigged example in that the data scientists created these two images themselves to trick the system into thinking they were of a guitar and a penguin. We won't get into the details here, but basically, the scientists preserved the elements that the system used to make those classifications and modified the rest of the image. Because these elements are completely different than the ones that you and I use to determine guitar and penguin, we have no idea what these images are supposed to represent. These are trivial cases that wouldn't usually have much real-world impact. But it would be more meaningful, to say the least, if this was a case where an AI-based system recommended that you should buy a stock that experts said was worthless, or that the black dot on your MRI was cancer. You, or at least your stockbroker or doctor, would probably want to know why the system made those recommendations. How would an explainable AI-based system actually work? The first thing to know is that the research is still in its infancy. There are many research efforts going on around the world. Some of them will probably succeed, but it's likely that far more of them will fail. Let me explain the high-level concept of how this might work. In the normal process of a typical AI system, there are a few steps. First, training data is identified. Then, it undergoes the machine learning process. Then, a learned function or algorithm is produced. Through this algorithm, the system can make decisions or recommendations to a user for a specific situation. However, the user will not know things like, why did the AI do that? Why not something else? When did the AI succeed? When does it fail? When can I trust the AI? How can I correct an error? As can be seen in this diagram, an XAI system could replace the traditional learned function with an explainable model. This model would be built in a way where the decision-making process could be understood by human beings. This process could be presented to the user through something like an explanation interface. As a result, the user could Though the field is early and rapidly changing, 3 of the more advanced XAI techniques are LIME, Retain, and LRP. Currently, the most common XAI technique is LIME. It stands for Local Interpretable Model Agnostic Explanations. LIME is actually a post hoc model, which means that it is a technique that looks for an explanation after the decision has been made. One benefit of LIME is that, as its name states, it is model agnostic, meaning it doesn't matter what type of model it is applied to. The LIME approach involves perturbing or slightly changing the inputs of the model to observe how the outputs change. This allows us to understand which inputs affect the outputs the most, giving us insights into how the model made its decisions. RETAIN, which stands for Reversed Time Attention Model, was developed at the Georgia Institute of Technology to study models that predicted heart failure. In this method, the model is designed such that, using the data from patient clinical visits, it can predict the occurrence of heart failure at a rate comparable to other models, but also identify which piece of clinical data contributed to the prediction. LRP, or layer-wise relevance propagation, works backwards through a neural network and figures out which input values were the most relevant in coming up with the output. Though these are 3 common XAI techniques being worked on today, there will no doubt be many others to come as the field develops. In the next 2 videos, we'll talk about why you might need XAI from the business and legal perspectives. In this chapter, we will talk about why the explainability of AI systems will be important for businesses. 2 of the core tenets of any successful business are accountability and trust. Customers and partners expect this from frontline workers in the store, factory, or warehouse, through middle management, all the way to the CEO and the board of directors. As AI systems start making more and more decisions that humans used to make, these tenets will be demanded of these systems as well. AI is now all around us. For consumer applications, it is embedded in things like Waze, Google Maps, Apple Maps, Siri, Alexa, Nest, Uber, Lyft, and so on. In the enterprise, it is already used in back-office systems such as accounting, HR, training and education systems, as well as for marketing, healthcare, finance, cybersecurity, and a whole host of other applications. For industrial applications, maintenance and operations systems, manufacturing and factory control, as well as design systems, all incorporate AI. The penetration of AI into the many facets of our lives will only continue to accelerate over time. As AI becomes more ubiquitous in our lives, there will be more and more areas of risk for AI that will need to be addressed. Examples include trust. Can we trust what the AI system is recommending to us? Can we trust that the systems were not developed using biased data? Liability. What happens when the systems make a mistake? Whose fault is it? Security. How can we know if the systems have not been maliciously manipulated? Control. Who, machine or human, has control of a process? If machine, then how can a human take it back? Because the consequences for inaccurate recommendations are minor for consumer applications, AI adoption has been more rapid. If your smartphone recommends a particular route to your house over another, or Amazon recommends a certain product over a different one, the implications, whether positive or negative, are relatively trivial. For decisions that have large financial implications, impact a very large number of people deeply, or have life or death consequences, adoption of AI has been slower. XAI may alleviate concerns over transparency, bias, and reliability and speed up the adoption of AI in these areas. For example, what if your AI-based medical system diagnosed some black spots on your scan to be cancer? Would you take that at face value and elect to have surgery or chemotherapy right away? Probably not. You likely would not 100% trust that decision. Currently, since you can't ask your AI doctor why it made that diagnosis, you would ask your human doctor. In addition to increasing the accountability and trust of AI systems in general, XAI will also help scientists and engineers improve the performance of AI systems within business. An explainable system will be easier to debug for unintended biases that may result from skewed training data. It will be easier to detect malicious hacks of explainable systems. Explainable systems will be easier for humans to work with, thus leading to man-machine collaborations that will perform better than just computers or humans alone. There will be a more detailed example of this in Chapter 2, the Centaur chess example. Here is another example where a business might benefit from XAI. A system may tell the agent how it made the decision to approve or deny loans to Although we talked about the many benefits of XAI, it is important to note that there are some significant challenges for the technology both in the short term as well as into the future. In this video, we will cover the difficulty in defining explainable, the potential loss of competitive edge for companies that incorporate XAI, The difficulty in understanding the explanations as they get more complex, the fact that some things are inherently difficult or impossible to explain, and the trade-offs that you might have to make to achieve explainability. First, the very definition of explainable is still in question. Explainable can mean everything from understanding the detailed actions of the AI algorithm to higher-level concepts of reasoning and logic. The current consensus among data scientists about the meaning of explainable seems to be that the system will tell you about its own strengths and weaknesses, the parameters it used to make its decision, why it reached a particular outcome as opposed to a different one, and the mistakes it's most likely to make and how to rectify those potential mistakes. However, to what level of detail does it need to go to be considered explainable? Some people have stated that justifiable, responsible, or transparent are better terms than explainable, as it implies deeper levels of logic and reasoning. As you can see, there are many different questions about the meaning of explainable. Another potential issue for using explainable AI is that it may compromise a business's competitive edge or differentiation. For example, making complex AI systems easy to understand by non-technicians or the general public may mean that trade secrets and competitive differentiation could be compromised. Understanding how a black box works may allow it to be copied or replaced by other solutions that perform similar functions. If the advancement of AI systems continues, it is conceivable that these systems will at some point become so complex that even the simplest explanations may be too complicated for the smartest humans to understand. Take the analogy of a nuclear scientist trying to explain the details of a complex differential equation to a kindergartner. Even though the scientist and the youngster are speaking the same language and understand all of the words being spoken, the concepts would be just too complex for the 5-year-old to understand. While this may seem to be science fiction or thousands of years in the future, with geometric, if not exponential, advancement of technology, this could happen much faster than most people expect. Another problem with the concept of explainability is that some things are just not easily explained. If you think about it, humans are actually not that good at explaining some of their decisions. We often make decisions based on emotion or non-rational factors, and then reverse engineer those decisions to come up with explanations. Some experts have said that in many cases, humans make decisions based on emotion, intuition, or other irrational reasons, and then they construct logical explanations after the fact to justify those decisions. You may be able to logically and rationally explain why you like pizza, why you picked the color of the car that you bought, how you ended up with your spouse. But chances are that a large part of the decision is based on emotion or other factors that may be hard or impossible to explain. If we are not able to explain our own decisions, some may argue that we should not expect computers would be able to explain their decisions either. There will likely be unacceptable or undesirable trade-offs in achieving sufficient explainability. These trade-offs could result from the fact that some approaches for creating XAI systems will involve rethinking how AI systems are developed. While some of these approaches may increase the output quality of the systems, we can expect that other approaches may lead to some degradation in the results due to changes in the algorithms that will be necessary for humans to comprehend how they work. XAI may not be the solution for every system. Some of the trade-offs of having XAI may be minor, but others might be more major. For example, on one hand, you might have a stock trading system that could make you $1,000 a day with XAI, but in doing so, it is inherently encumbered by the requirement to explain every decision. On the other hand, you might have another system that was making you $10,000 a day on average, but was a complete black box. I'd like to illustrate why it makes sense for humans and computers to collaborate with each other. To start, we'll discuss some things that humans are better at, and then some things that computers are better at. Finally, we'll talk about how XAI could make human-machine collaboration much better than it currently is. So let's get started on some examples of things that humans are better at than machines. First, let's look at some of the sensing abilities of humans. Though expensive machines now have the ability to see the world at the same resolution and same throughput speed as the human vision system, they are not yet widespread. The human nose, however, is still far superior to any mechanical smelling mechanisms out there. Finally, the ability of the skin to sense things like touch, fine temperature differences, and pain, and the tongue to taste will still be unmatched by machines for a long time. Humans are still far more creative than computers. Although recently there have been a few cases of computers making a painting or composing a song, by and large, humans are much more proficient in the creative fields such as design, art, architecture, music, writing novels, movie making, playwriting, creating new recipes, and so on. Next, let's look at the energy required for processing information. Currently, it is estimated that the human brain is about 1,000 times more efficient than a computer. To illustrate, let's look at some numbers. It is estimated that the human brain uses about 40 watts of energy to complete about 4 billion megaflops. Note that 1 megaflop is a million operations per second. The best supercomputers today need to consume 5 million watts to complete the same 4 billion megaflops. While it may surprise you that memory is on this list, take DNA for example. Every single one of our 6 trillion cells holds all of the information necessary to create your entire body. This is more efficient and compact than any hard drive. In addition, while digital media degrades over time, there has been DNA from Neanderthals dating back 30,000 years ago that are intact. DNA from other species from over 1 million years ago have also been found preserved. In addition, humans are much superior to machines in fine motor skills. Take your hand, for instance. It is composed of 27 bones, all finely connected and activated by numerous muscles and tendons. These all combine to be able to manipulate everything from threading a needle, juggling, to playing thumb wars with each other. It will take a long time before mechanical systems will be able to work so well together. In addition to the physical aspects, humans are still better than computers at processing certain types of information. Unstructured problem solving, or problems where the rules are not yet clearly defined, is one of these areas. For example, in a factory that has hundreds of machines and multiple ways each machine can be configured, you will have a massive number of ways these can all be combined to produce products. Using experience and intuition, an expert engineer could find the best process to develop a new product rather quickly. It would take a machine many hours, if it could do it at all, to do the same thing. Humans are much better at selecting and processing relevant information from a field of massive new information. For example, if a reporter goes to report on the elections of a country that has just developed democracy, she will be able to better identify and report on topics of most relevance. Humans are much better at other things like tasks that consist of non-routine physical work, such as cooking different meals every day for your family, or collaborating with many other humans, which happens in every medium to large company. Let's look at a graph with the horizontal axis representing the complexity of a problem and the vertical axis representing the amount of effort necessary to solve that problem. Initially, as a problem gets complex, it will take a lot of effort for a human to solve that problem. However, as the problem becomes much more complex, humans can start taking advantage of intuition and experience, or We'll now look at some areas where machines are better than humans. They are pretty good at games. Computers beat the chess grandmaster Garry Kasparov in 1997, and in the much more complex game of Go, one of the most dominant human players, Lee Sedol, in 2016. In 2011, IBM's Watson beat Ken Jennings, who had the longest unbeaten run at 74 winning appearances, and Brad Rutter, who had earned the biggest pot of $3.25 million. In the processing realm, the list is quite long and getting longer all the time. Machines are better than humans at things like numeric calculations, remembering massive amounts of facts without error, searching through extremely large amounts of information, and so on. Specifically, with the recent progress made in deep learning, as discussed in the intro video, AI has surpassed humans in many image processing tasks, such as identifying a large number of objects like faces in a crowd, or detecting product defects on the factory line quickly and in real time. In the physical realm, machines are far superior to us in many aspects. They are generally faster, stronger, more precise, feel no pain, and never tire. Other advantages for machines are that they are replaceable, replicable, reliable, obedient, and predictable. In fact, they have already started replacing people in entire jobs where tasks are repetitive and predictable, especially in dangerous or undesirable jobs. For example, machines are doing some of the following tasks that humans used to do: factory worker, switchboard operator, bowling alley pin setter, bridge toll collection, grocery store cashier, ticket sellers of all types, just to name a few. It is predicted that they may even begin replacing or heavily augmenting tasks of positions such as lawyers, photographers, customer service representatives, caregivers, and drivers. Going back to the solution effort versus problem complexity chart from the previous video, you can see that although computers can solve math problems with virtually no effort, complex problems where success can vary, such as planning a vacation, are next to impossible to solve. In summary, in these two past videos, we have discussed things that humans are better at and things that computers are better at. Humans are generally better at making sense of things in very complex, undefined environments. Most of the creative fields, such as art, music, and design, are still ours. Other than sight and sound, our senses are much more advanced, and we are able to better perform tasks that are non-repetitive and undefined. Machines, on the other hand, are better With the ever-increasing capabilities of machines, some people have predicted that humans will be completely replaced in the workforce. However, as discussed in the last section, there will be many human capabilities that would be far superior to those of computers for many years to come. By combining the strengths of humans and machines, we will be able to achieve much more than one or the other alone. XAI will make this a reality by allowing humans to better understand the quote-unquote thinking of computers, allowing us to better trust machines and their decisions. Let's discuss a bit more how a combination of computers and humans could be more powerful. Here again is the solution effort versus complexity chart. For a computer, things like mathematical calculations, for example, summing 10 sets of 3 to 4 digit numbers, is extremely easy. However, a complex problem where success is undefined, like planning a 2-week European vacation for a family of 4, would currently be impossible. Recall the strengths and weaknesses of humans mapped on the same graph. Doing mathematical calculations that are only a bit more difficult than multiplying 1-digit numbers quickly becomes a big burden on your brain. Quick, tell me what 352 times 918 is. A computer will of course easily tell you that it's 323,136. Alternatively, much more complex problems of planning a vacation, though not trivial, could be sufficiently accomplished by most adult human beings. Here are the charts overlaid on top of each other. So looking at this chart, combining the forces of humans and computers, you would want to be able to go to the left while staying as low as possible. And that is hugging the lowest portion of the two combined lines. It is stating the obvious that you would want to rely on computers to take on the easier problems of doing mathematical calculations or storing huge amounts of data. In addition, humans would conduct the more complex problem of planning for vacation, conducting non-repetitive tasks, and the like. To take this one step further, it would be even better to accomplish tasks as close to the lower dotted line as possible, where the effort necessary to solve a task is minimal even with complex problems. By working together, humans and machines could be more flexible, faster, scale better, and make better decisions than either alone. The benefit of explainable AI is that it will allow humans to better understand the rationale and have a deeper trust of the outputs and decisions made by computers, and thus allow for a tighter collaboration between humans and machines. XAI will help to increase transparency and increase collaboration of current black box AI systems. The problem is not that we are afraid that machines will intentionally deceive us or have any ill will towards us. It is that we cannot know if the decisions and recommendations made by the machines are based on the right data, the right set of reasoning, or the correct set of assumptions without deeper insight into the decision-making process. XAI will help humans to have more confidence in the outputs of machines. It will also help humans challenge the assumptions of machines to come up with better results. For relatively simple problems, this is not as important. However, humans and machines will need to collaborate extremely closely together to solve for massively complex problems such as trying to find a cure for cancer, stop global warming, ensure adequate supplies of energy, water, and natural resources, eliminate hunger and poverty, or create world peace. Before going there, however, in the next section, we will go through a chess example where a superior collaboration of amateur humans and regular computers resulted in far better results than supercomputers or expert humans alone. Now, let's go through a specific example of where this collaboration, when done well, is better than all other combinations. The example we will use in this case will be based on chess. Chess is a game that is played with 32 total pieces, 16 for each player, and is estimated to have at least 10 to the 120th power possible moves, which is far more than the number of atoms estimated to be in the universe. The sheer number of possible moves makes it so complex that even computers today have not been able to calculate all of the different outcomes, which makes it, as yet, an unsolved game. This makes it fascinating for computer scientists to use for AI. Since about the 1950s, programmers have been developing software to play chess. At first, progress was good, but relatively slow. But with the development of technology accelerating faster and faster, these systems continue to make solid progress over time. At the same time, the skills of human chess players developed much more slowly, if at all. It was inevitable that computers would be better than humans at chess someday. That day came on May 11, 1997, when IBM's Deep Blue defeated Garry Kasparov, the first time an AI beat a chess grandmaster. And since the curve for AI improvement is much steeper than for humans, we are no longer in the race. As a point of comparison, today's mobile phones are many times more powerful than Deep Blue was in 1997. Compressing the timeline down a bit, you can see that there is no hope for humans at ever beating the top computers at chess again. This then brings us to the conclusion that as of today, a strong computer is much better than a strong human at chess. However, Kasparov suspected that humans might have been helping Deep Blue in his match. We don't know if he ever validated that suspicion, but this led him to wonder what would happen if humans and computers worked together. From that idea, in 1998, the year after his big defeat, he held a freestyle chess tournament where teams of computers and humans, called centaurs, could play each other. Kasparov wanted to know if a human in the loop could actually help a computer beat a grandmaster in chess. Time went on, and in 2005, inspired by Kasparov's idea, an online freestyle chess tournament was held by PlayChess.com. Most online tournaments barred the use of computer-aided play. PlayChess wanted to see what combinations would be the best and allowed all comers. Competitors included Hydra, a supercomputer much more powerful than Deep Blue, as well as many types of other chess software, multiple human grandmasters, and other human amateurs, and a combination of the above. Not surprisingly, the addition of a computer to a strong human competitor was better than just a strong human alone. Since even a strong human is far inferior to a strong computer, the logical conclusion might be that adding a human to a strong computer would make that combination less effective than a strong computer on its own. For example, an elite tennis player would not be helped by adding an amateur tennis player onto the court for her finals match. However, that did not turn out to be the case. The combination of strong humans and strong computers consistently beat out strong computers on their own. Let's try to take a deeper look at why this might be so. Computers are inherently better at things like logic, computation, memory, and are consistent. Humans, on the other hand, are better at things like intuition, creativity, design, and finding analogies. Thus, one could summarize that with these strengths, the computers are better at humans in choosing answers. Humans, though, can be thought of as having better skill in choosing the right questions. It turns out that this is a powerful combination when trying to calculate the next move in a game as complex as chess. In fact, not only was the winner of the tournament a human and computer combination, it was a team of 2 young amateurs working with 3 weak computers. The 3 computers ran different types of chess software, and when recommendations were different between the machines, the humans interacted with the computers to analyze the moves further. Being able to combine the strengths of humans and the strengths of computers, which we will call superior process, was what allowed them to beat Hydra, one of the most powerful and sophisticated chess programs of that time. In fact, this combination also beat out other grandmasters that were also using computers, but using inferior processes. To summarize, it can be concluded that for certain applications such as chess, a superior process trumped superior humans and superior computers and their combinations. There have been other examples such as in fashion design, design of a quadcopter body, and art where these superior processes have yielded We'll look at a few more examples of how XAI may have benefits for us in our everyday lives. First, let's take a look at the very simple example of how XAI might help us have a better driving experience through a Maps application on our smartphone. Currently, you can have one of your favorite apps on your smartphone help you with directions to get from one location to another, say home to work. The Maps application will give you driving directions from your house to your office that is optimized based on time and a few other factors such as avoiding highways, tolls or ferries, or least amount of walking or number of transfers. It does take into account things like traffic conditions, train and bus schedules. Although it's far more convenient than using a paper map, it still does not compare to having an expert human that knows you well, guiding you from the passenger seat. Currently, companies are now in the process of adding other AI-based features, such as voice chat, as well as overlaying text and other information onto the real-world image through the camera, also known as augmented reality or AR. By adding conversation to the mix, as well as the ability to get more information about the real environment conveniently and quickly, these technologies will make the experience of getting directions much more rich and interactive. XAI will take this to the next level. For example, as the map makes recommendations to you, it will also explain the reasons behind recommend the way home from work. It can say, I am sending you via this route because I understand you currently have no meetings or other obligations for the next 3 hours. You've had a stressful day at work, and driving through winding mountain roads relaxes you. You could then correct any mistaken assumptions, such as that you actually prefer seaside drives. In addition to the simple interactions of the previous example, a deeper human and machine collaboration with your Maps app could be extremely valuable. Take, for example, a road trip that you're planning. The Maps application can become your expert transit advisor, suggesting spots that would be appealing to you, remind you to buy that souvenir for your neighbor who's watching your dog for you, or the nearest, cleanest bathroom. You are able to understand the AI much better because of the explainability feature. Thus, with XAI, your experience becomes much richer, you get the most relevant and accurate recommendations, and the system learns and improves much faster and more accurately than today's non-explainable AI systems. As in many other areas, AI has already started to significantly penetrate the healthcare and medical industries. Because of its ability to process huge amounts of data, AI is already a powerful tool in assisting doctors and other healthcare professionals for things like medical diagnoses and making healthcare decisions. AI is already being used in topics such as chatbots, oncology, pathology, and rare diseases. While doctors are using AI to assist in their work, machines will never fully take over tasks that are mission-critical or have life and death implications until human experts have a complete understanding of the inner workings of the system and how the decisions are being made. Not surprisingly, the importance of complete understanding increases with the applications that have higher consequences for errors. For things like making life and death impacting decisions or weighing the risks of critical diseases, AI tools are used to assist in decision-making, but the doctors will always have the final say. Let's see how XAI can benefit the medical and healthcare industries. First, Explainable AI will provide the transparency doctors and patients need to trust the recommendation of the AI system to be correct and in the best interest of the patient. This trust will be crucial for wider and deeper adoption of AI into the industries. In addition, when we go for medical treatment, we as patients want our doctors to be compassionate and connect with us. We do not want to receive bad news about our health from a cold computer output. Explainable AI could build better rapport with us and provide us with a more personalized interaction. Also, as we have seen in previous examples, AI is certainly not perfect. Systems can produce outright errors from not having the right data, and it could also produce biased outcomes due to the type of data that was used to train the system. For example, if the systems are trained predominantly on the data of one race, the recommendations and predictions may not be suitable for patients of other races. These biases could be identified from the explanations provided by an XAI system. Let's look at a simple example of how the type of data affects AI's output. There was an AI system that was trained to identify pneumonia patients with a higher risk of death. Surprisingly, it classified patients with asthma as having a lower risk, which was, of course, a mistake. The reason for this was that the pneumonia patients with a history of asthma were sent straight to the ICU to get the extra care that reduced their chances of dying. However, the AI system did not account for this. The explanation of an XAI system for the same prediction would be obvious that the outcome was not true. Let's revisit the cancer example we saw in Chapter 1. You visit your doctor for a regular checkup. After going through the standard body scans and blood tests, you sit back and wait for the results. Unfortunately for you, the message today is not a good one. You are told that the analysis of a scan found a very high probability that you had cancer and that you needed to undergo surgery immediately. If the analysis of the scan was conducted by an oncologist, you could ask things like, why do you think it's cancer? Couldn't it be something else? How do you know it's malignant? And so forth. Additionally, your doctor could confer with the oncologist and they could have a discussion between the two experts to come up with an even more accurate and detailed diagnosis. None of this would be possible with a conventional AI system. You cannot ask it why, nor can other experts confer with it. An explainable system may be able to do both. Give you, the patient, an explanation, and also be able to collaborate with the doctor. Marketing is another industry where the use of data has exploded recently. In this video, we'll explore some examples of how AI is already being used by marketers to improve their craft, and then talk about some of the limitations of the current state of AI. Finally, we'll go over an example of a company that says that they are already incorporating XAI into their product. Many aspects of marketing and sales have become digitalized today. The ability to collect vast amounts of data about the market and the customer have greatly benefited marketers and salespeople. Sites such as Google and Facebook make massive amounts of money, being the best at serving the most relevant ads to the right people for the right price. Marketing automation tools such as HubSpot, Marketo, Constant Contact, and Pardot have made sending customized campaigns to target customers very easy. Customer Relation Management, or CRM tools such as Salesforce, Infusionsoft, and Pipedrive help digitally manage and forecast sales pipelines. These tools, among others, already utilize AI to create better search results, smarter ads, better content, more personalization, customized content and messaging, among other things. But one of the major limitations for AI in marketing is that it cannot explain why it made a certain marketing decision. In order to evaluate the decision, the marketer must actually implement it in the real world to see what the results are. This is, of course, a costly and time-consuming endeavor. Let's look at a typical customer targeting example. Currently, marketers use AI to cluster potential customers and come up with a prioritized list of the top segments to target for campaigns. These AI systems are trained using data from the results of past campaigns as well as other relevant data. Once the system comes up with the prioritized list, the marketer currently cannot get any additional information from the AI. Using XAI, the marketer can evaluate the reasons for the segmentation and use intuition and experience to improve the campaign. A company called SimMachine, who makes XAI-based software for the marketing industry, is already doing this. In the course of a typical marketing campaign, there are several steps, including data source integration, modeling and segmentation, campaign execution, campaign measurement and feedback, and finally, the financial results. which can usually take anywhere from 4 to 7 months. By using XAI, the system explains why it makes a certain prediction, allowing the marketer to get more directly involved in the decision-making, leading to more accurate results and a reduction in the campaign length by 50% or more. Selling products and services can be a difficult task, especially things that are very expensive, commoditized, or new to the market. Enterprise sales of large systems or customized services can be especially complex, time-consuming, and hard to manage. Salespeople use AI-based tools to make these tasks easier. Currently, these tools help track opportunities, recommend next actions, and assign probabilities of a deal closing. With an XAI-based system, a deeper collaboration between machine and human can be likened to having a sales expert to consult and bounce ideas off of all of the time. Here is an example of how XAI might help you with online shopping. Think about your favorite online shopping site. As you are shopping, it's very likely that the AI on the site will make recommendations about other items that you might be interested in. The AI makes these recommendations using data collected from you, from other similar customers, and a variety of other factors, including time of year, for example, Christmas, Black Friday, summer, fall, winter, spring, etc., time of day, and other information. With Explainable AI, the system can explain to you why it made these recommendations. The chatbot system can initiate a conversation with you about these recommendations. Through these interactions, the system will learn what your Let's look at the example of online fraud detection. This is another area that has massive amounts of data being collected, and the data scientists are already using AI to catch criminals stealing money from the system. One of the problems is that the bad guys are using AI tools to do their dirty deeds. In addition to the fact that the number of targets, such as e-payments, virtual goods, cryptocurrencies, etc., are undergoing massive growth, some other reasons fraud is so difficult to contain include the fact that, while there are certainly cases of large attacks and breaches, a huge number of fraud cases are in the tail, meaning they are small but occur in huge numbers. It is often conducted by professional criminals, both with technical and financial expertise and plenty of resources to work with. These professionals are nimble and can adapt to countermeasures extremely quickly, and there is a disincentive for firms to crack down too hard because too many false positives, which is identifying something as fraud when it's actually legitimate, turns off customers and is bad for business. Firms are already using AI quite extensively to combat this precisely because it can address the big problems of fraud. AI is automated and can analyze huge amounts of data in the long tail. Even if criminals change their tactics, AI is also able to adapt to an extent to respond to these changes. AI is one of the most sophisticated tools available today to combat professional criminals. And finally, because AI improves accuracy, companies can afford to crack down harder without the fear of punishing legitimate customers. But there are certainly limitations on how effective AI is in fraud detection. For instance, many fraud detection algorithms are based on the techniques of anomaly detection, which is where the machine searches through massive numbers of patterns and identifies the ones that are dissimilar or anomalous to the others. That means if you do something that is not similar to your past behavior, or the past behavior of people with similar profiles as you, the algorithm will flag you as suspicious. However, just identifying the anomalies is not enough. As you must know firsthand, human behavior is often not consistent with past behavior. For example, take the instance of a large charge being made to your credit card for a refrigerator purchase at a home appliance store. Is this okay? Should this be approved? With that information alone, it is hard to determine if this is fraud or not. However, if the XAI system could also explain to the analyst that there were 2 more separate charges for refrigerators on the same day at other stores, you would know that there is a higher likelihood that this is fraud. Banking, insurance, and financial services are heavily regulated industries. Thus, technologies that are used in these areas will need to be carefully vetted and scrutinized. As discussed before, AI will reach an adoption hurdle due to its black box nature. XAI will be necessary to meet the transparency and accountability requirements of the regulators. There are a few companies that have already announced products that are based on XAI. FICO, One of the major credit rating agencies has a product called Reason Reporter that they say is using XAI. When an anomaly is detected, Reason Reporter identifies which input data caused the detection. This system is similar to Lime, but according to FICO, it actually fared better when the two were tested side by side. Although they have not announced if any of their products are using it, Capital One, one of the largest U.S. banks, announced through the Wall Street Journal in as early as 2016 Although there is currently a lot of excitement about XAI, it is important to note that it is still very early in its development as a technology. We'll discuss the current state of XAI and put it into perspective compared to how other technologies were adopted in the past. To give you some perspective, let's take a look at how long it took for some new technologies to get adopted. Electricity, for example, was discovered in 1873, and it took 46 years before 1/4 of the population began to use it. The telephone, invented 3 years after electricity, took 35 years for 1/4 penetration. And of course, there are a huge number of technologies that had high expectations, but for a variety of reasons were never successfully adopted. A few examples are Iridium, the satellite phone, vehicles, and Token Ring, if any of those are familiar to you. AI itself took a while. The logic theorist, which is thought to be the first artificial intelligence program, was developed in 1956. The field of AI expanded quickly until about 1974, when the lack of computational power led to very slow growth for the next 10 years. AI had a small resurgence from government funding in the 1980s and continued to build momentum from private funding started in the 1990s. Today, with a dramatic reduction in the cost of computing power, storage, and sensors, we are in the golden age of AI. The market research company Gartner publishes a chart annually called the Hype Cycle for Emerging Technologies. In it, they rate the conception, maturity, and adoption of emerging technologies. In the past, it recorded the development of things like cloud computing, IoT or Internet of Things, and Bluetooth. AI is all over this year's curve, including deep learning, AI platform as a service, conversational AI platforms, and even artificial general intelligence. However, XAI is so early that it doesn't even appear on the Gartner hype curve yet. This is one piece of evidence it is still very early in its life. XAI will likely follow a similar development path as AI, albeit a much narrower one. In other words, by definition, all XAI applications will be AI applications, but not all AI applications will need to be XAI. There will be a host of organizations that create the supply of XAI. Universities, government, and other research organizations are already starting research into XAI. For example, DARPA, the R&D arm of the U.S. Department of Defense, is already investing billions of dollars into XAI research. Technology companies that are already investing significant portions of their revenue into AI will take XAI into commercial pilot as well as real-world applications. As we saw, companies such as Sim Machines and FICO have already announced products that use XAI. AI companies like Bonsai, DataRobot, and Kindi have also announced products and platforms with XAI. On the demand side, fields where traditional AI is being used but adoption has slowed or stopped due to concerns about transparency or trust will initially drive demand for XAI. As we discussed, the medical and healthcare industries are some examples of this. Today, AI is being used for some applications in these industries and will continue to grow. However, as adoption increases, concern about transparency, trust, bias in the data, accuracy, etc., will presumably inhibit growth in the near future. Once success is demonstrated by these early adopters and the cost of developing and implementing XAI decreases, other fields will follow. Though XAI is currently experiencing a small but rapidly growing amount of attention, there is no guarantee that XAI will even end up being a viable technology. However, with the limitations of AI and a significant amount of effort put into XAI, there is a good chance that it will become an important technology in the future. Thus, it would be beneficial for people to continue to pay attention to the state of the art. As we have discussed, XAI could be a powerful and differentiating technology for your business. As we discussed in the previous video, it is still very early in development. Thus, not everyone will need to invest in it right away. In this video, we'll discuss how you might think about what to do about XAI. Specifically, we'll cover questions such as, should I invest in XAI? If yes, where and how much? And what else should I do about XAI? XAI will be more important to some types of applications and less so to others. Thus, it is important to understand what type your business is. The horizontal axis here represents the amount of technology that you use in your business. The more technology, the further right you would be, and vice versa. An example of a company on the right would be an internet advertising company who absolutely depends on technology to run their business. An example of a company on the left would be a bakery. Though one could argue that bakeries could benefit from technology, most bakeries today clearly do not use AI in their everyday operations. The vertical axis represents how mission-critical or life and death your business is. An example of a company near the top would be a hospital where life and death decisions are made many times a day. An example of a company near the bottom would be a baseball cap manufacturer. Starting from the top left and going across, we'll name these quadrants 1, 2, 3, and 4. Think about where your business would sit on this matrix. Focusing on the horizontal, most technology-heavy companies located on the right have already started incorporating AI into their businesses. These include the platforms such as Google, Amazon, Facebook, Apple, and Microsoft, who are already deeply committed to using AI in their businesses. XAI will be the next logical step. Now, looking at mission criticality, applications that are high on this chart would include law enforcement, space exploration, national defense, healthcare, medicine, firefighting, and 911 operations. One tier lower, but still critically important, are industries such as automotive, banking, finance, and law. The higher you are on this axis, the more important AI and XAI will likely be for you. Bringing these axes back together, you can see that XAI will be most important to technology-heavy applications that are mission-critical. The weight of being a tech application is heavier than that of being mission-critical. In other words, even non-mission critical applications will benefit from XAI if they are technology-heavy. Thus, XAI will be most important for applications in Quadrant 2. In particular, XAI will be especially critical for applications in this quadrant that are fully automated without human in the loop. Examples here include medicine and healthcare, the military, and self-driving cars. Also in Quadrant 2, XAI will be important for applications that would benefit from deep human-machine collaboration. Things here include things like meteorology or factory automation. Next, Quadrant 4 applications such as social networking, e-commerce, internet advertising, and smartphones will also benefit from XAI. Finally, applications in Quadrants 1 and 3, those that do not use much technology, whether mission-critical or not, will be the last to adopt XAI. These would include policing in Quadrant 1 and hat making in Quadrant 3. In addition to the technical merits of XAI, companies may also benefit from the branding value by adopting XAI. Similar to how companies today are touting things like AI, machine learning, blockchain, and IoT, if done right, companies can get reputational benefits by announcing to the public that they are using XAI or that they are XAI compliant. Particularly, if you are in industries that are highly competitive, use technologies in modest to high amounts, and fast-moving, you may be perceived as a savvy early adopter by branding with XAI. Of course, there must be substance behind this messaging as well. So what can you do? If you are in Quadrants 1 or 3, the left side of the chart, you are likely okay just keeping tabs on the development of AI and XAI. If you are in Quadrants 2 or 4 and are relatively new to AI, you should start by learning more about AI. In addition to attending some of the large numbers of AI-related conferences, you can join organizations or programs such as OpenAI, DARPA, and Partnership in AI. There are a large number of introductions to AI courses available here on LinkedIn Learning that you could take as well. The next step would be to hire a data scientist, initially as a consultant if you are not ready to take a big leap, or as a full-time employee if you are. If you are already deeply immersed in AI, then the next step is to start experimenting with XAI. Have your data scientist learn about the recent XAI developments, such as Lime, Retain, and L. I'm very happy that you decided to join me in this course on the very nascent but exciting topic of XAI. If you start now, you could be involved in using and shaping a technology that is still very early in its development before it potentially becomes much larger. It may follow a path similar to the one technologies like cloud, IoT, or AI itself did just a few years ago. For those of you just starting this journey, you may want to look at some of the many books, courses, papers, websites, and other material available on AI, particularly for industries that are technology heavy and or have mission critical applications. It would be a good idea to really start thinking about how XAI might improve your business. For those of you ready to make a bigger investment, look into hiring consultants or even full-time data scientists to explore and develop XAI POCs or proofs of concept. You can also learn a lot more from DARPA, who is investing billions of dollars into XAI R&D with a large number of partners. They have posted information on their website about their motivations, as well as the current state of the art of explainable technologies. You will also be able to see on the DARPA site who their partner companies and universities are. These partners have also started to publicize some of their work in XAI. For example, my company, Park, has posted on the company website about the DARPA-funded project to develop explainable systems for automated drone navigation. Park also works with other companies in developing AI and XAI technologies. Thanks for spending some of your valuable time with me. If you have any questions during your journey, feel free to reach out to me via LinkedIn. Good luck to you, and I hope to see you in another course soon.